Hello everyone, welcome to the session and today we will be discussing about karst landforms. These landforms are specifically developed with respect to the groundwater action, and yes, these landforms are also being developed wherever you see the deposits of limestone, wherever you see the deposits of these gypsum. So when we have this deposition of gypsum, limestone, and to some extent this dolomite as well. So if you see the deposition of these minerals, if you see the deposition of these minerals in the crust parts, let's say with respect to the beneath to the surface, and as a result of the groundwater action, as a result of fluvial action, though it is taking place at ground, we discussed about the fluvial landforms, running water, but that was with respect to the surface water. Now we are talking about the fluvial action with respect to the groundwater, and these topographical features were actually discovered by one person called Karst, so the name is given accordingly. So we have to see that as a result of groundwater action, obviously on the soft rocks, obviously on the rocks which are more prone to weathering or more prone to erosion, there we will have a formation of specific topographical features, and we will be given name to each and any specific particular slope or any specific particular shape which would lead to the changes in the topographical surface itself. So when you see this karst landform is basically the we can say the combination of erosional and depositional features. Yes, the weathering is also there. We have already discussed about these aspects in our previous session. So whenever there is a weathering of limestone, whenever there is a erosion of dolomite, or whenever there is a deposition, when we have a gypsum deposits, or let's say these rocks, if they are there at any particular depth at our crust, so we will see some sort of topographical features in this way. So suppose this is your surface, and we may have a water which will going to pass through it as a result of this limestone topography, or it could be dolomite, or it could be gypsum to some extent. So there will be a particular shape, and we will going to see which particular shape is there and what name can be assigned to that particular topographical feature. So first of all, these are actually the result of that chemical dissolution which is being done by the water. These are actually the result of the carbonation with respect to the limestone. These are the result of hydration of limestone. I hope you remember in the chemical weathering we discussed about these things. So as a result of chemical weathering, first of all, as a result of the fluvial action of water, there will be erosion, there will be a deposition. We will see that so many topographical changes are there which are taking place here with respect to this particular, we can say, shape. So first of all, what we can say, that whenever you see the soluble rocks, these limestone, dolomite, and gypsum are the soluble rocks, there you will see this limestone topography. They used to best developed wherever you see the dense and tiny bedded rocks, wherever you see the carbonate rocks, especially the limestone, where the limestones are plenty, when they are denser, you will see if there is a running water, or if there is some sort of water which is percolating from the ground towards the interior parts of our earth, or let's say which is coming from the top surface groundwater to the subsurface, we can say, to near to the crustal parts. As a result of this, erosion and deposition will take place. So whenever we have these soluble rocks, limestone specifically, so at the surface and the subsurface level, there will be a water which will lead to the highly erosional aspect with respect to the surface or with respect to the subsurface nature. So here you can see we will have a formation of caves, we may have a formation of some sort of underground lakes as well. And if you put an artisan well here, if you put a tube well here, you can get a water from here as well. Okay, they act like a natural reservoirs from which you can actually fetch water. So how they will going to form, what specific features are there, let's have a deep dive on that. So first of all, suppose here we have a surface. Okay, this is what the surface, and this surface is comprised of limestone. This surface is comprised of what? Limestone, or in general way, or in broader way, you can consider that this is the part of crust, and here we have these sedimentary rocks. Specifically, there is a limestone. Okay, Now, whenever there is a water, suppose there may be a water because of the rainfall, suppose there may be a water because of, let's say, to some extent, as a result of irrigation as well. So when we have a rainfall, so what will happen? We will have what? We will have a limestone event and we will have an action of water. I hope you remember chemical weathering. So there will be an action of water and limestone all together. When there is an action of water and limestone all together, I hope you remember there will be a washing away of some sort of rock material. And yes, the characteristics of rocks will also change. Anhydrite was actually changed in gypsum. I hope you remember. So the action of water with the limestone will lead to what? Formation of one depression here. There will be formation of one depression here. Depression means what? Depression means whenever we have a sharp changes in the features. So here the topography is like this. Here the topography is like this. Now this could further widen if the water is continuously percolating, or let's say if the water is continuously present here, what will happen? This will become what? More, you can say, broader. Then ultimately it will become more broader. Then ultimately it will become like a particular Uvalas, and yes, lastly it could take a shape of Poljes. So what we can say, whenever we have a small depression which is actually being formed as a result of this solution where the rainwater is there, when we have a limestone at the top, so there will be a formation of what? Sinkhole. So this depression is what? Sinkhole. First of all, there will be a sinkhole. Now if there is a continuous water action, as a result of that, the sinkhole will further wider, and when it will become more wider, that the name will be given, that will be a shallow swallow hole. That will be swallow hole. So when the water will continuously sunk, as a result of this, it will lead to the formation of what? It will lead to the formation of swallow hole. If there is a number of swallow hole, if there is a number of swallow hole continuously, if there is a number of swallow hole continuously formed on the surface itself, so they might, resulted into the formation of large hollow. Collectively they might become like a large hollow, and when we have a large hollow, that large hollow will be given name as doline. That large hollow will given a name as doline. Now many of these doline might going to have a some sort of merger. These dolines might have a some sort of subsidence as a result of gradual action of water, and it will further widen. And if it will going to further widen, we will have a formation of Uvalas. So Uvalas will be formed, and we will have a greater depression which we are referring as Uvalas. And yes, lastly, if we see this particular Uvalas, so we may have a more broader and steeper slopes. So when we have a more broader and uh, slopes, especially the steeper slopes, so that will be called as what? Poljes. So here in this poljes, water can be collected, and this poljes is act like a lake here. Valas will have a some sort of, we can say, the gentle slopes. Okay, Valas will have a some sort of gentle slope, but because of the action of water here, the slope would become modified. So this is how, suppose we have a limestone, when the water will be there, a small depression will be there. If the continuous action of water will be there, as a result of that, this continuous expansion will take place, and ultimately we will have a formation of the landforms in this way. And we are talking about the surface now. These topographical features used to look like in this way. From surface we are talking about. Okay, from surface we are talking about. So here you can see like this is the doline. Okay, when we have a many dolines all together, and if they will crush, yes, we may have a formation of what? Uvalas. So these all landforms are dynamic. The action of water is also what? Dynamic. Continuous action is there. So there is a continuous modification in the topographical features. So there is a continuous changing in the orientation of these particular slopes. At a one time, with respect to their appearance, we used to give name accordingly. So sometimes there might be a possibility that many of the lines might, collapse together, they join together, then we have a formation of Uvalas. If the Uvalas will further subjected to, we can say, weathering or erosion, we will have this particular lake which is formed, that is referred as what, Poljes. Okay, so these kind of topographical features would be there. Polje is a large flat plain depression which is found in the karst or whenever we have a limestone region, and it have what, steeper walls and flat floor is there. They have what, flat floor, and it act like what, lake. Polje lake it would be. It would be Polje lake. Okay, it would be Polje lake. So here you can see again, for example, we have a sinkhole, a small hole is there. Now that hole might modified, and I hope you remember this entire thing will going to take place on the entire limestone topography. At one place there might be a doline, there might be a sinkhole. At another place we may have a same thing with respect to the changing nature, with respect to the time period. At a one place there might be a formation of Uvalas because of the continuous action of water. Similarly, at the other place on that limestone topographical feature, we might not have same kind of action. That's why it's a humanities subject. Have a logic, but don't have a universal scientific application. So on this entire topographical feature, we will have a difference rate of these evolution of these landforms. These landforms are subjected to evolve with respect to the time period, with respect to the action of water, and as a result of this, I hope you got to know about this particularly order. Sinkhole, then we have a swallow hole. If they will going to collect together, there will be a doline. If many doline will come together, they will form Uvalas. If Uvalas is there, further subjected to erosion, polges will be formed. So this action will going to take place at any particular part of this topographical feature. It could be here, it could be here, it could be here, it could be here as well. Okay, and they are dynamic. They used to change. Then we have a karst window, and this is what the name given to a particular slope appearance. Okay, so we have a karst window. Karst window means what? Like whenever we have so many sinkholes, and if these sinkholes will going to collapse completely, they're going to collapse completely, and when they will going to collapse completely, as a result of that, they will going to form a one open and broad area, and this open and broad area is actually connecting with respect to the outer part, or let's say the outer topographical feature, that will be act like what, window, that you can peep out from windows. So similarly you can peep out from this particular limestone block from the outside. So this supposed to be like this, but as a result of, we can say, as a result of continuous formation of sinkholes and dolines, they collapse all together, and yes, this end was visible towards the other surface, and that's how we have this particular formation of karst window on this side. So window means you can see through it. So you can see through it, and yes, rest of the topographical features are on this side. I mean, just for example, just for visualization, I'm trying to adding. I have tried to add more and more images here so that you will get a more clarity. But as far as these features are concerned, you just have to focus that how they used to look like. All right, so we have a like a evolution of these landforms, continuous evolution of these landforms. So when there is a opening of, we can say, one portion of this limestone topography through which you can see, or let's say through which you can have some sort of passage kind of appearance, so that will be termed as karst window. So that's how we have a karst window.